as we continue to work on integration, the functions that we're going to work on have a linear relationship in there. So ax plus b, where a and b are constant terms. And we're going to anti-differentiate those. So before we get to that part of it, we're going to go and just do the derivative of each of them. And then we're going to learn how do we anti-differentiate with those functions along the way. So the very first one that we have is e to the x. So instead of it being e to the x, it's e to the f of x. So there's that f of x that's in there. That's the exponent part of it. So therefore, when I take the derivative of this, so dy dx, the derivative of e to the f of x is e to the f of x times the derivative of the numerator. The derivative of the numerator, 3x plus 2, is just 3. Okay, so that's my derivative, and feel free to bring that 3 in the front. Okay, I'm going to kind of smush for space here. Okay, so for the second one, now this has a power, so it's a function to a power. So therefore, the derivative, dy dx, we drop the power in front, we multiply it, we drop the power, and then we take the derivative of the inside. And then, of course, we multiply the 5 and the 4 to get 20. Okay, but what you're noticing is every one of these has functions that are within there. So now for part C, I take the derivative of the natural log of f of x, which means dy dx. The derivative for the natural log of x is 1 over f of x times the derivative of the inside, so times 7. So I'll just put the times 7 up top here. So it's the derivative of the inside over f of x. And then cosine, so dy dx. The derivative of the cosine of x is the negative sine of x, but since it's a function, it's the negative sine of the function times the derivative of the function, which is 3. Again, we can toss that 3 in the front. And then the last one is with the sine. Derivative of sine of x is cosine of x. So therefore, dy dx equals the cosine of the function times the derivative of the function. So that should say cosine of 5x plus 1 times 5. So again, just remembering how do we actually take the derivative of these, because now when we try to undo that derivative, we have to remember how we also always have to take the derivative of that linear piece. 5, 3, 7, 5, 3. So that way we don't lose those pieces that we have to then multiply on. So when I have a function, and when I am integrating a function, when it's e to a function, the integral is going to be e to that function times 1 over the derivative of the function. Okay? So that's always that just constant term that we have that goes in there. Okay? So going through each of those pieces, take a moment, take a look at all of these, pause it if you need to. But again, we're always going to be looking at just taking the derivative of that part. Now, we specifically are talking about a linear piece, but we'll be able to work on more than just linears. We'll have some other oddities that are going to come through, and you're going to see them in our examples. So we need to integrate this 4th degree polynomial. So one of the things that you could do is you could expand it all out, and you could write 2x plus 3 times itself 4 times. We could do binomial theorem and expand it out that way. Whatever seems to make sense to you. However, what we're going to end up doing is using what we just worked on, because we know that that's a linear function that's inside of there. So therefore, for a, this is equivalent to, so just like always, 2x plus 3, that goes to the 5th power. However, since it goes to the 5th power, we then have to divide by 5. And then I also have to undo the derivative of the inside. So undoing the derivative of the inside, the 2x plus 3, I'd have to take the derivative of that, which is 2. Therefore, I have to divide by 2. Because when I take the derivative, I multiply by 2. Therefore, I have to divide by 2. And then don't forget the plus c. So you would traditionally see this as 1/10 times 2x plus 3 to the fifth power plus my constant term. Next one. First thing, I'm going to rewrite that integral as 1 minus 2x to the negative 1/2 power dx. So therefore, when I go through and do my derivative, it's 1 minus 2x. That's now going to go to the 1/2, which means I'm going to have to multiply by 2. Dividing by half, same thing as multiplying by 2. And then I'm going to have to undo the derivative of the inside. The derivative of the inside is negative 2. Therefore, I'll have to divide by negative 2 and then plus my constant. Therefore, this is equivalent to negative 1 times the square root of 1 minus 2x plus c. So take your time with square roots, especially because of those negative exponent ones. Next one. Now we have some e to the x, or e to the f of x's. So for the first one, anti-differentiating, the first one would be 2e to the 2x, but then I'd multiply by that exponent, so I have to divide by it, minus e to the negative 3x. I'd have to take the derivative of that, so therefore I have to divide by that negative 3, plus c, and then of course simplify that. That's e to the 2x plus 1/3 e to the negative 3x. If you wanted to put e to the positive 3x in the bottom, that works perfectly fine as well. Totally your choice. Plus c. And then the next one, I cannot have that 4 technically up top, so I can rewrite this as the integral of 4 times 1 over 1 minus 2x dx. So this is sometimes the hard one to see. Whenever it's 1 over x, you're thinking natural log. Okay, maybe you're not thinking that, but you need to think that. Remember, natural log is when it's 1 over something with the x. That's the integral is the natural log when you integrate that. So when I integrate this, I get 4 times the natural log of that function. But then I'd have to then attach on that times negative 2 when I do the derivative. Therefore, I have to divide that by negative 2 plus c, which gives you negative 2 times the natural log of 1 minus 2x plus c. And then the last one we're going to work on has some trig functions. So integrating with respect to x. So what does that mean? The integral of 2 sine of 3x plus 4, or plus cosine of 4x plus pi. Remember, pi is just a number, it's x. So that's why we just have that linear function inside there. So now when I integrate, so the derivative of the sine of x is negative cosine of x. So therefore, it's negative 2 cosine of what we had, 3x, but then I'd have to attach on that times 3. So therefore, we're going to divide that by 3. Derivative of cosine is sine. So therefore, this is a sine of 4x plus pi. But when I take the derivative of 4x plus pi, then I have to divide by 4. I'd be multiplying by 4, therefore I have to divide out the 4. And then plus c. Which then gives me, I'll just rewrite this, negative 2/3 times the cosine of 3x plus 1/4 times the sine of 4x plus pi plus c. And then if I gave you any coordinate points, we could then plug those in and find our c value. And then we would have all of our integration.